Today we're going to consider finding probability of independent and dependent events. So we're looking at events that are linked, but there's an important difference between the two. Independent events are such when the occurrence of one event does not affect the occurrence of the other. For instance, flipping a coin twice in a row, the outcome of the first flip has no effect on the outcome of the second. Shooting 3 free throws, it doesn't matter whether the man makes or misses his first, he has an equally probable chance of making the second one. The dependent event is such when the occurrence of one event does affect the occurrence of the other, in particular when it changes the probability. So it's important to write this down, maybe in the margin of your notes page. The question you want to ask yourself is, does the first event change the probability of the second event happening? If it does, for instance, if there's fewer items overall outcomes, then that would be a case of a dependent event. If the first event does not change the probability of the second, then the events are independent. So let's look at a couple of examples. Say, for instance, you're presenting projects and a teacher is selecting students at random, and you get selected first, and then one of your classmates, Kim, is selected second. Are those events independent or dependent? And you may say, well, it doesn't matter. Like, if I got picked first, Kim was always going to get picked second. But we're not thinking about it from that direction. We're thinking about this in the sense of, do you being selected change the probability of Kim being selected when a second person is taken? And it turns out that yes, it does. After you're chosen, there's one fewer student from which to make the second choice. So if there were 20 students in the class, you had a 1 out of 20 chance of being selected. Now when Kim is selected, there's only 19 students remaining from which to select. She has a 1 of 19 chance. You flip a coin and it shows heads, and you flip it again and it shows tails. Are these events independent or dependent? Well, we use that as one of our examples at the top of the video. Those are independent events. What happens on the first flip does not affect the second. And the third example, so 1 out of 25, a model of a digital camera, has a random defect. So you and a friend each buy one of the cameras, and you both get the defective camera. So is that an independent or dependent event? You getting a defective camera and your friend getting a defective camera. Because the defects are random, you getting the defective camera doesn't affect your friend getting a defective camera, so those events are independent. What I'd like you to do now is take just a couple of minutes, talk it through with your table groups, and write 2 examples of independent events and 2 examples of dependent events. And remember, the important piece here is, in a dependent event, the selection in the first event changes the probability of the second event. And in class, we can talk through some of your examples. So let's look at some examples of calculating independent and dependent events. So the probability that B will occur after A has occurred, or in math terminology, given that A has occurred, is what's called the conditional probability of B given A. And the way we write that is probability and then our parentheses for the event, and B with a vertical line, and then A. So our first probability comes from a sample. A high school has 850 students, and we look at how many of each class attended a concert and how many did not attend. So our 2 questions: what's the probability that a student at the school attended the concert? Okay, so that one seems pretty straightforward. Total number attended divided by the total students if you select it at random. And we find out that 564 is the total number of students who have attended. That's adding 80 plus 132 plus 173 plus 179. And divide that by the total number of students at the school, 850. And we get 0.664, so a 66% probability that a student at the school attended the concert. Now it says, what is the probability that a junior did not attend the concert? Well, so that's the probability that a student did not attend given that they're a junior. So we're taking the number of juniors who did not attend, which from the chart we can see is 29, divided by the total number of juniors, which is those who attend and those who didn't. 173 and 29 gives 202. Dividing those out gives us a probability of about 14.5%, 0.144. So if you remember back to Friday when we did the Mathlicious exercise, the 3 free throws, we were calculating probabilities of independent events. We were looking at probability of making a free throw or 2 free throws or 3 free throws out of a group of 3, and we found that the probability of making 2 or 3 or 1 was the probability of each one multiplied together. And that's actually the formula for calculating independent events. Probability of A and B happening is the probability of A happening times the probability of B. If we have dependent events, then the probability of A and B is the probability of A times the probability of B after A has happened. So for instance, the number of possible outcomes has changed. So as an example, selecting 2 cards from a deck of 52, the question is, what's the probability that the first card is a heart and the second card is a club? And there's 2 conditions here. So the first case is we replace the first card before selecting the second. This is important. Oftentimes in math problems, you'll see the terms with replacement and without replacement. So when we select that card, we're putting it back in the deck, replacing it. So there's still 52 cards when we select the second. So the probability of the first card is a heart. Okay, so there's 4 suits: hearts, diamonds, clubs, and spades. So the card would be 1 out of 4, 13 out of 52, probability that it's a heart. Now we put that card back, still 52 in the deck, and so there is a 1 in 4 chance that the card we select second is a club. So 1/4 times 1/4 equals 1/16 is the probability of randomly selecting 2 cards from the deck and having the first a heart and the second a club. The second case is we do not replace the first card. So we take the first card out and then we don't put it back. So now when we select a second card, there's 1 fewer cards in the deck. So let's walk through this. There's a 1 in 4 chance that the first card we select is a heart, because 1 out of every 4 cards is a heart, 13 out of 52. Now we've taken that card out of the deck and we ask, what's the probability of selecting a club after we've already selected a heart? So there's 51 cards in our deck now. 13 of those are clubs because we took a card out that wasn't a club. And so now we multiply those two fractions together, 1/4 times 13 over 51. The numbers get kind of big and ugly, but it's 13 over 204. So that would be our probability of selecting a club after selecting a heart if we did not replace the card first.